For the following question, you must show all your working out and calculator methods are not allowed. So part I, find algebraically the coordinates of the points of intersection of the curve y equals 4x squared plus 24x plus 31 and the line x plus y equals 10. Points of intersection, we're doing simultaneous equations because they will have the same x and y coordinates. So to do this, I am going to rearrange my linear equation to make, I'm going to make y the subject because it's going to be easier to substitute y in here than it is to substitute x in. So if I make y the subject, it will be equal to 10 minus x. I can now replace this instead of the y here. So I'd get 10 minus x is equal to 4x squared plus 24x plus 31. We are now going to take the 10 away from both sides and we're going to add the x to both sides, which gives this. Now I'm going to try to factorise this if I can. Remember, calculator methods are not allowed for this question. It's got to be a 4x and an x to get a 4x squared. And to get the 21, well, it could be just a 21 and a 1. If I put a 21 here and a 1 there, let's just check that. The 4x times the x gives the 4x squared, of course. The 21 times the 1 gives the 21, of course, but crucially, most importantly, the 4x times the 1 gives 4x, and the 21 times the x gives 21x, and the 4x and the 21x do give the 25x. So I know I've got that correct. So therefore, the x coordinates of the points of intersection are minus 21 over 4 or minus 1. Those are the x coordinates of the points of intersection. I obviously need to work out the y coordinates as well, because it does say just find algebraically the coordinates. It doesn't say the x coordinates. This is coordinates, so I need x and y. So we are now going to substitute both of our x values in here to work out the y coordinates. So when I substitute the minus 21 over 4 in, let me just show you my working out for this. It'll be 10 minus 21 over 4, which is the same as 10 plus 21 over 4. The 10 is the same thing as 40 over 4, so I get 61 over 4. Now to substitute in the minus 1. So we'll get 10 minus 1, which is 11. So our points of intersection, our coordinates of intersection are, we've got the coordinate minus 21 over 4, 61 over 4. That's one coordinate, and then we've got the coordinate minus 1, 11. Right, part II, or part 2. It says express 4x plus 24x, so 4x squared plus 24x plus 31 in the form a, x plus b all squared plus c. So that's completed the square form. So I want to complete the square on this. Now, I don't like the fact there's a 4 at the front there, so the first thing I'm going to do is factorise that 4 outside. So taking the 4 outside, I'll have a 4, then I'll have the x squared, then I'm going to have a 6x, and I'll keep the 31 separate over there for the moment. So just to double check, 4x squared, 24x. Plus 31. This is the same thing. Now let's complete the square on the inside. So I'm going to half the 6. I'm going to take away that 3 squared. Now I'm going to multiply both of those terms, both the x minus 3 all squared and the minus 9. I'm going to times both of them by the 4. So 4 lots of the x plus 3 squared, 4 lots of the minus 9, plus the 31, which is 4x plus 3 squared minus 5. So that's my answer to part II, where A is 4, B is 3, and C is minus 5. And finally, for part III, or part 3, for the curve y equals 4x squared plus 24x plus 31, we need to write down the equation of the line of symmetry. So, if you're not sure about this, I think me drawing a quick sketch will help you for this. It's really obvious once you can sort of picture what's happening here. So for this quadratic, we know it cuts through 31 on the y-axis. We know its turning point is the coordinate minus 3 because of this, minus 5 because of this. So minus 3 minus 5 is like roughly down here somewhere. The x-coordinate is minus 3, the y-coordinate is minus 5. Which means then that my quadratic is going to look something like this. Actually, let me redraw that, that's not very good. A little bit better. Right, so there's my quadratic. The line of symmetry will always go through the turning points. That is my line of symmetry there. Quadratics always have a line of symmetry passing through the turning point. The equation of that line is x equals minus 3. Every point on this line has a coordinate minus 3. Therefore, that's the equation x equals minus 3. Like I said, we didn't need to draw the graph for that. We could have just looked at the 3 there and the minus 3 there and said x equals minus 3. But hopefully it makes sense why with the sketch. Part B, write down the minimum y value of the curve. Well, we can see that the smallest the y value can be is minus 5.